Hello! In this video, we're going to look at SQL databases and how to use them with Python. So let's just do it. So to start off specifically, we're going to be using SQLite. SQLite is just a way to use SQL databases. It just makes a file, a local file, which is really simple. It's often used within mobile devices. It's really fast, but it's all around just really good. Link in the description for how to download this and install this, depending on your platform. So before we jump into the code, I'm going to just explain really quickly what SQL is. SQL is a relational database that allows you to create tables which contain information. A table is basically, you can kind of think of it like a spreadsheet, and it has a specific set of columns that you can define. And then a row within that table is an entry within the table. So as an example, if we look here, I have this users table where we would have an ID. This is a column. I know it's kind of a little bit confusing because this looks like a row, but I'll show you just more in a second. So this is an ID, which is a column. This is a primary key, which is why you see this little key here. Then we have a name, which is text, and then an age, which is an integer. How might that actually look if you were looking at it when it's printed out? Well, it would look something like this. This is just a spreadsheet, but basically what this looks like is ID, name, and age. So in this case, the ID for the first user might be 1, then 2, the name. So this is the single row, this is another single row, and that's basically how it works. Now, one of the things that's really strong about SQL databases or relational databases is that it allows you to join separate tables together to perform actions or to perform a single query. So without further ado, let's just jump straight into it. All right, so to start off, we're going to want to go ahead and install DB SQLite 3. So this is just a pip package, which is going to allow us to interact with the database nicely. First things first, if we run this, it's going to go ahead and create a mydatabase.db file within the same directory as the main file. You can put that wherever you want. You can set whatever directory you want for this. We're then going to create a cursor. A cursor is going to allow us to execute queries. So it's pretty important. So if I go ahead and run this, you're going to see that nothing happens because we're not really doing anything with it yet. But we can see that the mydatabase.db was created on the side. So that file does exist. If we go to it, it's empty. Even if we went to it and it wasn't empty, probably couldn't read it because I think it's all, bytes and stuff. So, all right. So we have a database, but we don't have any tables in it. So let's create a table. All right. So to go over the query, basically what we're doing here is we are executing using our cursor, and we're providing this block of text. This text says create table if not exists, the users table. So we're going to create a table if the table doesn't exist, and we're going to call it users. Then the definition for this users table is whatever is within these two parentheses. In this case, we are defining an ID, which is an integer, so a number, and it is the primary key. You can kind of think of the primary key like the key to a dictionary or some kind of unique identifier for a given row. It will always be unique, or it has to be unique. So if you're trying to insert something else into the table and it has the same primary key, you're going to hit an error. Next is the name, which is, in this case, text. You could also do something like varchar and specify a specific amount of characters that you would allow. And then we're going to say that this can't be null. That means that if you try to insert something into this table and the name is not provided, you're going to get an error because we're saying you need to have a name. The next column is the age, and it's of a form integer, basically just another number. And in this case, we're not saying it's needed, so you could have a row within this table where the age is not defined. Pretty sweet. So we now need to actually add something to the table so we can do things with it. So let's go ahead and do that. So we're going to insert into this table. So when we do this, we use the exact same thing, cursor.execute, and then we again pass it a block of text. In this case, we're going to say insert into the users table, specifying the name and the age columns that we want to add, the following values. And these values are comma separated. You don't always have to add 3 at a time. You can add a single one and it would look just like that. Totally fine. But I'm just showing you here that you can add multiple. Now, you might be wondering, why are we not adding the ID? Because I just said that we need the ID, right? It's very important. The one thing that's really handy about a lot of SQL databases or implementations of SQL is that it allows you to not specify the primary key because it's going to keep track of what the next one is. Because if you're inserting something into the table, it knows that, well, you can't insert something with the same primary key as the previous one because that's not allowed. So you probably want a new one. And then it's going to keep track of what the next new one would be. Otherwise, you would have to read the database, figure out what the next primary key could be, and then write to it with whatever those values could be. You can specify it, but you never really need to, at least for inserts. All right. Then we're saying specifically the values, and then again with brackets, each set of values. So this John Doe would correspond to the name, and 25 would correspond to the age. Pretty sweet. So if we go ahead and run this, we also have nothing happen. Again, we're not actually printing anything out here. So totally expected. If we go to our My Database file, you're now going to see that there is some stuff in here. It's pretty weird looking though. A lot of nulls. So yeah. All right, next thing we're going to do is, well, we have stuff in our table now. So let's read from our table. So we're going to go ahead and do just that. So I'm going to uncomment this code here. And basically what this code is doing is, again, we're executing. This is just a single line because it's pretty simple. But what we're doing here is we're going to say select star, meaning every possible column from the given table or tables, spoiler alert, from the given table. So this in this case, users. So select star, select every column from the table users. Now, that might seem kind of interesting, right? So we're going to get the ID, the name, and the age. And what this returns when we actually call cursor.fetchAll, because it's basically going to fetch all of the, execute everything, fetch everything, and then grab it here, is the rows from this execution. So in this case, we're going to get everything back from this, and we're just going to print them all out. So let's go ahead and run this. And there we go. We can then see that we get 1, 2, 3 for the primary keys, John Doe, Jane Smith, Bob Johnson, 25, 30, 22. So this corresponds to a single row. Awesome. But what if we want only the name from the table? Well, we can just specify name. And we see we get doubles here because I inserted into it twice. So let's go ahead and delete the database and rerun it. There we go. So we get the names. So that's also pretty neat. But what if we only want it where, maybe a little bit more specific, right? We don't want all the users because what if we have thousands of users or millions? Well, this is where you can add a where clause, if I can spell where properly. And in this case, you could say where the age is greater than 23 or 4, I guess. And in this case, if we run this, let me comment this out so we don't add more people to the database. If we do this, we're going to only get the users where the age is greater than 24, and specifically the name. So if we do this and run, we're going to see we get John Doe and Jane Smith, which based off of what we were adding here is correct. Now, whenever you're going to actually use a query, you're going to want to try to filter whatever you can from the database as much as possible. This is meant to be extremely fast, and it will probably be faster than your code. No shade at your code. So try to filter it when you can using the where clause. And you can just do as many of these. You can say and, or you can say where age is greater than 24 and age is less than 28, or name equals Bob. Bob. And then we can run this. Oh, I didn't save. And then we can run this and we can see that we only get John Doe. Because the name equals Bob does not actually work. Now, why doesn't that work? So why doesn't Bob work? Bob doesn't work because we're specifying that the name has to equal specifically Bob, but the name is actually Bob Johnson. So what you can do is you can say and then you can specify, you can then use the percentage character to basically act like a kind of like the star, where anything before this text or anything after this text. It can be whatever we want. So if we run this, we should then get Bob Johnson because it's saying that, okay, we're accepting anything before and anything after. So is Bob in any of the names? In this case, it is. So now we get John Doe and Bob Johnson. Pretty cool. Okay, great. But what if we have more than one table? Well, we can solve for that too. So let's go ahead and create some more tables. So in this case, don't want to comment that out. Okay, here we're going to create the table called posts. And it's going to have an ID, which again is the primary key, a user ID, which references the user from the other table, and then the message, which is some kind of text. We're then going to insert into the posts table the user ID and the message, and the values 1, 1, and 2. And these are going to correspond to the users from the users table. Okay. Then what we're going to do is specify the messages. And then finally, once that's all been inserted, we're going to then execute a select query where we're going to select specifically the user's name. So from the users table, the name, so the name column, and from the posts table, the message, so that the text. Then we're going to get this from the users table, but we're going to join the users table with the posts table. On is kind of like saying where, except it's used for when you're joining two tables. So on posts.userid equals users.id. So this is basically saying that if we have an instance of a user where there is a post within the posts table where the user ID is equal to the ID within the users table, then we should consider that a single row. Now, let's see what happens when we run this. Now we get John Doe, hi YouTube, subscribe, wink, wink, nudge, nudge, and then Jane Smith, which says, wow, cool stuff. Now, you might say, well, okay, but why are there two John Does here? There's two John Does here because there's two instances where the user John Doe, which is corresponding with 1 because it was the first user we added to our data or to our users table. There's two instances of this. So this means that we're actually going to be creating a row per instance of this posts table. So pretty cool. Just to kind of give you a bit of an idea of what that kind of looks like, here's a little bit of I don't know if this is useful, but this is kind of what we're doing here. So we're saying that like a user can correspond to any number of posts based off of this post or this user ID. So there can be, this is a one-to-many relationship. That's what this 1 and star mean. So there can only be one user with a specific ID, but the posts can have as many posts as you want with the given user ID. Pretty sweet. I'm going to actually leave this in the description, a link to this, because this is a super useful image here. Basically, it just allows you to kind of understand all of the joins you can do with SQL. So I specifically just talked about join, which is somewhere on here. It's not even on here. I think it's the default with it, which I think is left join. Basically, what that means is that if you're doing a left join or just a join on table A, you're going to get everything from table A all the time. And then you're going to get parts of table B that only exist that are only related to table A. So kind of interesting. Actually, you know what? Maybe it is an inner join because we didn't get the other users. So it's probably an inner join. We can actually test this out by if we just comment this out. And if, we can comment all this out actually. We can comment that out. And then let's do left join. What did I do? Oops. Yeah, there we go. So in this case, if you did a left join, so it does do an inner join by default. And if we do a left join, that means we get all of the users no matter what. And then, so we still get John Doe because there's two instances within the post table. We get Jane Smith, but then we get Bob Johnson, but we say that there is nothing for the message because they don't exist. So I'll leave this because I literally printed this off and have it at my desk because remembering how all of these work is a little bit confusing. So anyways, I'll leave this. I did not make this, by the way. This is from Code Project. So props to them for making some handy little images. So how might you actually use this in the real world? Well, in order to do that, I made a really simple little website using Flask on how you can do that. I'm not going to go over how all the Flask stuff works. I'll just go over the SQL parts. So basically, we're going to initialize this when I call site.py. So we're going to create the website. It's going to create the database using this initdb function. So it's just creating the database. And then when we go to the root for the website, if it's a post message, we're going to get the name and the age. This is when we're inserting something into the database. And we're going to insert into the users the name and the age. And in this case, we're using this, this little question marks here, which allows you to specify things based off of a value, an actual a variable value. The reason this is way better is because you don't have to do like the plus name plus. That's what you would have to do otherwise, and that's terrible. So, yay question marks. Cool. And then the next thing we do is then query to get all of the users. Here's another handy little keyword here, which is count. But basically here, we're then selecting how many users, so all of the users, are there from the users table. If we specified like a where clause here, then it would only say how many of the users match this query, basically. Finally, for the search, we are trying to get a search query. And then we're saying select star from users where name is like this. And this is kind of just like what I showed you earlier with Bob, where we're specifying a search query. All right, so let's go over how this website works. So we're going to go ahead and navigate to the site. And here we are. Pretty beautiful, I know. So basically what this allows you to do is, just like I said, you can insert users into the database. So let's go ahead and add Drac, solid Drac. So we can go ahead and submit this. I don't know Drac's age. I would never guess an age. So there we go. We have one user in the database. If I then add myself and I say I'm 32, because I am, then there we go. Now we have two users in the database. If I go over to the search, I can then search with no query, and we can now get Drac and Jake. Pretty cool. But what if I just say AK? In this case, we're going to get both again because AK is in both of our names because of the like query. If I say Jake, I'm only going to get me. So yeah, I'll have all the code, by the way, from this up on my GitHub in a link in the description. So if you want to play around with any of this, feel free. Let's talk about updates though, because we haven't actually gone over an update yet. All right, so I've gone ahead and updated this here, where we're now going to be selecting the users from the table, just like we were before. Then I'm going to be calling update. So update, basically you can say update, and then you specify the table, and then you say you're gonna set whatever you'd like to set, and this can be as many things as you'd like. And then you say where, and then the name, in this case, is like Bob. So I'm gonna set it for Bob. So let's go ahead and run this. All right, so I did make a mistake here where you need to make sure that the connection is not closed. Closing the connection is always important because it basically is telling that the cursor and the connection to the database that it is done. So you want to make sure that you close them as soon as you don't need to use it anymore. So let's go ahead and run this. And we can see to start off, we're selecting the users. We get our Bob Johnson with 22, which is what we inserted into the table way up here. And then we call our update, which is update users set age 32, where the user's name is like Bob. And then we select again, and we can see that now Bob is now 32. Bob has aged 10 years in a split second. Pretty cool. All right, one final thing I wanted to mention really quickly is transactions. Now, this is not something that's necessarily going to be useful for every single person out there, but it's something that can be really important to know about. So what is a transaction? A transaction allows you to perform a number of queries in whatever order you need them to be done in, but it ensures that all of them have completed, and otherwise it rolls everything back. So you begin a transaction, you perform a number of queries, and then you end your transaction, or you commit your transaction. And if at some point something happened, then it rolls it back so that whatever you have done so far doesn't actually get committed to your database. Now, why is that important? So let's give a simple example here where we own a bank, lucky us, and we decide that we are implementing our reading our withdrawal or our moving some money around implementation for our bank accounts. And we basically have to do 4 steps for that to happen. We read the balance of bank account A, then we read the balance of bank account B, we reduce the balance of bank account A, and then we add the balance to bank account B. So say, the user is withdrawing $5 from A and putting it into B. We need to know how much money are we reducing or like updating the value within bank account A, right? What is the now total within bank account A? And then also what is the new total within bank account B? So this is fantastic, right? This should work, no problem. But one issue is that we might actually, what if we fail right here? Then we have read the balances, we've reduced the balance, we've made the withdrawal from bank account A. But if we error here and we never finish number 4, and we just, error, we kill the program, then we never really added the money back, right? We've taken the money and we've just left it. So we're going to have a lot of angry customers and maybe get sued. So that's no good. So what you would do here is you would do this within a transaction so that you ensure that if you are reading this information and writing this information, if at any point any of it fails, so we hit an error, it will undo all of it. So that's something that you should probably don't have to do that often, but if you ever run into an issue like this, which I have, not specifically for a bank, it can be a huge pain. So just as a heads up that this is kind of important. All right, that's it. That's SQL. I hope you found this useful. If you did, please drop a comment down below because engagement, but also it's great to hear if people like my stuff. And while you're down there, maybe hit the like button and subscribe. I'm going to be posting again at least once a week for the remainder of the year. That's the goal at least. So yeah, I hope to see you around. In the next video, we're going to be tackling the human benchmark still. It's a lot of fun. We're going to do the chimp test. It actually worked out very well, surprisingly. Simpler than you might think. Just a little bit of tedious work. So yeah, anyways, check that one out next week. And that's it. Remember, I'm Jake. You're awesome. And this has been SQL. Cheers.